In this video, I'll talk about JDBC performance and connection pooling. Now, when we talk about JDBC performance, one of the first points of distinction is the underlying technology used to connect to the external database. These days, most major databases provide high-quality JDBC drivers written in pure Java and that connect directly to the remote database. However, this isn't always the case. Some databases have no network protocol, or they use custom native code libraries. For example, to connect to a Microsoft Access database, which only has an ODBC interface, you would need to use what is called a JDBC ODBC bridge. JDBC developers have names for 4 different types of drivers. Type 1 refers to a JDBC ODBC bridge. Now, ODBC was originally developed by Microsoft, but is now a native standard for accessing databases across many platforms. A Type 1 driver connects to a database via ODBC. Prior to Java 8, there was a JDBC ODBC driver built into Java, but to date, Oracle discourages its use and recommends going to a commercial or an open source alternative. Type 2 refers to drivers that make use of the Java native interface and native code to connect to the database. Type 3 refers to drivers that are written in pure Java, but they require the installation of another middleware server that translates between the Java communication and the native database communications. A Type 3 driver will connect to the middleware server, and then that server will communicate to your database. So there's that intermediate layer. Finally, a Type 4 driver is written entirely in Java and connects directly to the remote database. That means that the developers of the Type 4 driver have implemented all of the database communications protocols in Java so that the network connection is direct without any intermediate systems. Type 4 drivers are generally preferred by Java developers. This is because it tends to be more portable. It will run on Unix, Windows, and Mac. It's usually faster, it's less resource intensive, and it's more reliable and requires less installation. So, if you've got a choice, the best bet is to go with a Type 4 driver. Now, earlier I said that most major databases provide high-quality JDBC drivers written in pure Java that connect directly to a remote database. So now you should recognize that what I was really saying is that most major database vendors provide Type 4 drivers. Now, Type 4 drivers are usually the fastest, but how fast are they? Unfortunately, opening a database connection can be quite a slow operation. I ran a simple benchmarking experiment on my computer. I opened and closed millions of connections to a database, and then compared it to the time it takes to just recycle that connection millions of times using something called a connection pool. It turns out that opening and closing a connection takes just over half a millisecond. And this sounds like a small number, but if you're trying to handle 1,700 requests per second, then the only thing you'll have time to do is opening and closing connections. Instead, recycling connections is over 100 times faster. There's a small overhead in ensuring that the connection is returned to initial state and managing the recycling process, but just like in real life, it is very good to recycle. Connection recycling is made possible using what's called a connection pool. A connection pool is a connection of established connections. When you create a connection, you get one from the pool, and when you're done, you return it to the pool. This code example is a rough idea of how a simple connection pool would work. On startup, you see it creates 10 connections. Then with each request, instead of getting a new connection, you just take one from the pool and then return it to the pool when you're done. Now, this code has many problems, but that's okay because you don't have to write your own connection pools. JDBC driver developers and application servers already provide high-quality connection pooling facilities for you to use. So how do you take advantage of a connection pool? Well, instead of creating a connection directly, you request a connection from the application server. In this example, I've configured the application server, so there's a JDBC connection pool named JDBC/AIP. Calling getConnection on this data source will retrieve a connection from the pool. When the connection is closed, the close command will be intercepted and the connection is returned back to the pool. I'll talk about the meaning of the initial context.doLookup later. It relates to naming and directory interface of a Java EE application server. But for the time being, you can just remember it as a kind of magical incantation. Actually, there are many benefits from getting connections from the connection pool. Not only do you get the performance benefit of connection pooling, but you also get simplicity and centralized configuration. When the application server is responsible for managing the connections, the configuration is all in one place. You don't need to include connection strings or usernames and passwords in your code. In fact, the application server lets you change the settings while the application is running. In addition, the application server provides a wide range of monitoring tools that would be difficult to write yourself. Okay, so the two important things to remember from this video are: you should request database connections from the application server rather than managing it yourself, and you absolutely still need to remember to close your connections. In fact, it's probably even more important because the container might put a limit on the number of pooled connections that are allowed.